Okay, so here we have the manual from the organ that I picked up. And in all days, they would not only just give you the manual, but they would give you something called a schematic. So a schematic is something that's very important for you to understand if you are trying to build a circuit. What a schematic will do for you is it'll tell you what building blocks, we talked about those building blocks before, some of them, so a resistor, uh, diode, and capacitors. What is the combination of the building blocks or the Lego blocks you actually need to make a working circuit? And as you can see here, we have the power amplifier and the power supply down here. So it breaks down exactly what kind of power you'll be able to get from the power supply of the organ, which we're going to reuse. So I'm going to turn to page 8 right there. And if we take a look here, we have a schematic for our organ power supply. And I promise I'm going to explain all of this stuff to you. So all the schematic is doing is it's explaining what components is inside of that circuit and what components need to be connected to each other for it to work. So each of these building blocks has a symbol, right? So a diode, which we have pictured here, is very similar to the symbol that we have for a diode. So the banded end of the diode corresponds with this little mark that we have going to the left and right. So it says that it's supposed to touch another diode, right? That's over here. So the banded end of that diode of a new diode is going to touch the non-banded end of this one. So as you can see, you can actually line these the schematic up with the building blocks or the Lego blocks that you use in order to make the circuit. So it says that we should have two of these components touching. A resistor, what does a resistor look like in a schematic? It's this wavy line. And if you think of electronics, electricity as a bunch of folks that are trying to run on a road, as you can see, as the folks run on this road, they got to go through lots of turns and twists. And we know that the shortest path is a straight line between 2 points, right? So what the resistor does is it provides friction or resistance against electrical current. So that's why it has this symbol of a wavy line. Okay, so if we take a look at another component that we have on our schematic, we have here a capacitor. So what the capacitor does is these types of capacitors that are larger and can store more charge are called electrolytic capacitors. And they have a positive end and a negative end. And if you look at this capacitor, you see that it has a line with some negative signs that point to the bottom. So it tells us that the negative end of this capacitor is on the bottom, okay, which is right here. And then the positive end of the capacitor is at the other end, which is here. So we're going to have a capacitor in this circuit. Okay, now we're going to take our organ power supply, and if you take a look at it, it actually gives you values that you can get from the power supply of the organ. So it tells us that we're going to get plus 18 volts and minus 18 volts. Okay, and we need to have at least 12 volts in order to run our power section for our Leslie. Okay, and it tells us that we can get plus to minus 18 volts, which is going to give us anywhere between 20 to 25 watts of output power from our power section. Now, what exactly does a power section do? What a power section does is it allows you to grab power from the wall. Okay, the power from the wall is called AC, or alternating current. What that means is that the current goes positive and then negative, positive and then negative. Let me show you. So if we have an x-axis, the current is going to go positive, then negative, then positive, then negative, then positive, then negative. Okay, and this is actually this looks very similar to the signal that would come out of a guitar. The only difference is that when power comes out of the wall, you're going to get every second that passes, you're going to get 60 of these waves. Okay? Whereas if we think about a concert A that a violinist plays, when they play, they're going to get their note repeated, or the cycle that creates their note 440 times a second rather than 60. So we tend to, when we get power from the wall, we don't want this positive to negative current swing, because it looks a lot like an audio signal, and it is an audio signal. It actually sounds, 60 hertz sounds kind of like this. And the issue with that is if we're trying to reproduce music, we don't want that frequency on top of our music because it's noise and we don't want it. So what comes after we plug into the wall is a bunch of components that we use to take this signal that goes from positive to negative at a certain frequency or note, and we want to turn that into a signal that's just flat. Okay, and that signal is called DC, or direct current. Okay, there's a bunch of different ways to do that. I'm going to point you to an Uncle Doug video that uses a technique called the full wave bridge rectifier to turn your alternating current signal that goes from positive to negative to a DC signal. Okay, which means we don't have that positive to negative flow, and our power is not going to have that hum on top of it. It's just going to be clean and it's not going to make any noise. Okay, so we're in essence taking the power section that we have from this organ and we're using it to provide the power that's needed for our power amplifier section. Now, why do we need power for an amplifier? Well, in order to make signals louder, okay, we have to provide power to a component or a set of components called transistors. Okay, what transistors do is it takes electrical current from the wall or from your power supply, and it uses that current to amplify or make the signal louder, music signal louder that you pass in. Okay. Now, let's take a look at our actual organ power supply. As you can see, they give you colors. It says, hey, you're going to have some red and yellow wires that your power is going to pass through. And once it passes through those red and yellow wires, we're going to give you plus and minus 18 volts. Okay, so now the red and yellow wires that they were talking about are actually up here. It's a little dusty, but you can see the red and yellow wires here. So it's going to pass through those red and yellow wires. We're going to flip this chassis around so you could take a look on the other side. And as you can see, we have those same red and yellow wires right here. Okay. And if you take a look, I've already labeled the wires here. We have your wire that's going to give you your negative voltage, okay? And here we have the wire that's going to give you your positive voltage, okay? And you see how it's tied to those red and yellow wires that we talked to coming out of the chassis. So there's another symbol that I failed to talk about in the schematic, and that symbol is here. This is called a power transformer. So what a power transformer does is it takes your voltage from the wall and it allows you to increase the voltage or decrease the voltage. In this case, we need 18 volts. 18 is much less than 110 volts that we get out of the wall. So we need a transformer to convert that high voltage that we're getting out of the wall down to a voltage that we need later on in our circuit. So one of the things to note about the power amp circuit that we would like to use is the power amp can only accept a voltage as high as 70 volts. So we need to cut down the amount of voltage that we're going to feed our power amplifier. And one of the first steps for doing that is by connecting your plug to a power transformer, which will step the voltage down for you. So this is our full wave bridge rectifier, okay? That will convert that positive to negative signal that has the hum on top of it to one that does not alternate from positive to negative and doesn't hum, called DC. So that's the purpose of this. And this is something called a choke, which further takes out that ripple that happens 60 times a second and eliminates noise. That's also the function of these two capacitors that we have here that's in our diagram. And that is a look at our power section. So I'm literally taking the positive and negative voltage from our power supply from the organ. So here is our power transformer. Here are our two chokes that help to cut down the amount of noise from our power supply. And that's it. I literally connect the power wires to where my power amplifier needs power. And that's it for part 4 of the Build Leslie amp for guitar.